Okay. So, do you all see this sheet on the screen, revision year 12 electromagnetism?
Yes.
Okay. So, there are four basic things that we will be looking in today's revision of electromagnetism topic. So first is the force on a current carrying wire, and second question is about how that force can be used to make a motor, and third one is the force on a moving charge in an magnetic field, and fourth one is the electromagnetic induction. So so I will post this worksheet also. So if you could do these four questions, basically we will cover everything that is required for the electromagnetism topic. So here, for first question, mag- magnetic field is always from north to south. So there is a magnetic field exists between these two north and south poles, which is to the right, and the current is going from here to this direction. So this arrow is representing the direction of the current carrying wire. So whenever there's a current carrying wire will have its own magnetic field, and these two magnetic fields interact, and therefore it will experience a force and it will move. Now that force is formula for that force is BIL. B stands for the magnetic field, I stands for the current, and L is the length which is inside the magnetic field. So using this formula, we can calculate the force, and it is called the magnetic force. Uh, Now, how do we find the direction of this force? We use right hand slap rule. So if you could now extend your right hand, so your thumb is pointing in this direction along here, kind of into the page, and I'm putting my hand like that. Sorry, you can't see me right now. And your fingers should be in the direction of the magnetic field, that's to the right of the page. And if you look, if the direction in which your palm moves is downwards, okay? So that will be the force. So this wire will move downwards, okay? So that's how we can find the direction of the magnetic field. So there are some questions here, and I have posted the answer. We'll post the answers also. You can go through those one. So that's the basic for this one. Now, the principle of this rule, it is called motor rule. That's how the DC motors work. So what we have called is this blue coil, a rectangular coil, which is placed in a magnetic field. Now, current will be coming. So this is positive current will be coming from here. These are called brushes and commutators. You don't need to know the details of that, but current will come from there. It will pass through there. So current is going like that, around like this one. Now this side over here is similar to like current was going there. So it will experience a force in a downward direction. This side will experience, because current in this one is in an opposite direction, so this side will experience a force in an upward direction. Now this part of the coil, I'm talking about this blue coil which is carrying the current, it does not experience any force because lines of magnetic field and this direction, they are parallel. So therefore no force is experienced by this side or this side or that side. Force is only experienced by this side and that side. So say for example, uh, whatever the force is, we use BIL. Length will be this length of the wire, B is the magnetic field, I is the current to calculate the force. But then there are four loops, so we will multiply it by 4. So force will be 4 times more. Then there's a force on this side also. And if this is the axis of rotation, so what happens is this side will experience a force downwards, this side experiences a force upwards. So, or in other words, it is experiencing a turning effect or a torque. And how do we find the torque? Torque is force times distance. So the total force that we've calculated for 4 loops times the distance will give you the torque which is created by this side. and then equal amount of torque will be created by that side, or in other words, this coil will rotate. So if we are looking from this side, it will be rotating in a clockwise direction. So that's the basic principle of the motor rule. Third thing that we look in this topic is, if there is an electron which is moving with a certain velocity and it is entering the magnetic field, in a current, there are positive charges in conventional current that move. So the wire experiences a force because there are charges moving in this one. So those charges are inside the wire, but here they are loose. So this electron will experience a force. Now, if it was so, to find the size of the force, formula is F equals BQV. B is the magnetic field, Q is the charge on this one, and V will be the speed. Okay, and that's given in your summary notes. Now, to find the direction, we use right-hand slab rule again. But this is an electron. So if electrons are moving this way, that means if there was conventional current, that will be moving to the left. So now, if you could extend your right hand again, place your thumb to the left of the page, and your fingers should be pointing into the page, because these crosses means magnetic field is into the page. So if you've done it correctly, thumb to the left, fingers into the page, your slab is moving down the page. So that means that this electron will experience a force down the page. It was moving in this direction. If there was no magnetic field, it will keep moving in this direction. So force is at 90 degrees angle. If force is forward, then it accelerates. If force is backward, electron will decelerate. But force is at 90 degrees angles, it will move in a circular path. So this electron, because force is there, it will move in a circular path like that one. So this BQV, that is the force experienced by the electron, that makes it move in a circular path. And this force is, we call it centripetal force, because it's just making it go in a circular path. So BQV equals mv square over r. We can calculate the radius of the motion. Instead of electron, if it was a positive charge moving in this direction, then obviously use your hand again, right hand. Your thumb will be to the right of the page. Your fingers should be into the page, and then your slab moves up the page. So then, if this was a positive charge, instead of moving straight, it will experience a force upwards. Therefore, it will move in a circular path like this one, as I'm pointing with the cursor. So that's the force on a moving charge. And last thing in this one is electromagnetic induction. And what is electromagnetic induction? It is opposite to the motor effect. Remember, in question 2, we looked at the motor. So motor effect is produced. So current and magnetic field together, they produce a force or a motion. This one is opposite. Force or a motion and the magnetic field, there is no battery here, that will produce a current or a voltage. And because there's no battery, it is because of the action of the magnetic field and the movement of the conducting rod. It is called induced voltage or induced current. So let's look at this one in a little bit detail. So formula for this one, induced voltage is B, V, and L. Capital V is the induced voltage. B is the magnetic field, which is given from north to south to the left. V is the speed by which this wire is moved. And L is the length which is inside the magnetic field. So what happens is, so this is a conducting rod like made up of copper. And copper has got charges like atoms, which can move from atom to atom, and those one have got the electrons. So when you move this rod, it is cutting the lines of magnetic field, and when it cuts the lines of the magnetic field, those moving electrons will create a magnetic field, and this magnetic field and that one will actually make the electrons move either this way or that way. So if electrons experience a force this way or that way, that means that current has been produced. So remember, size is BVL, and to find the direction, now we use right-hand generator rule, which is slightly different from the right-hand slab rule. So now, if you could place your right hand again, what you know are your thumb and fingers, and what we're looking for is the direction of your palm movement. So if you could place your thumb down the page in the direction of this one, of the right hand, and your fingers should be from north to south, the direction of the induced current comes out from A to B. And this is the conventional current. That means positive charges have moved from A to B. And if positive charges have moved from A to B, that means this end will become positive and this end will become negative. Just for a minute, assume there's no wire here and there's no wire here. It's only the rod. So during this movement, this rod has become like a little battery. It has induced, there is a voltage being induced here. This side has become positive, this side has become negative. However, in this diagram, there is a complete circuit through this galvanometer. So current will come out of the positive and it will go like in a clockwise direction like this one. Okay, so that's the electromagnetic induction, and it will be, so remember, formula is BVL, direction is by using right-hand generator rule. These are just some brief answers, but I have also given you some kind of detailed answers, which I can show you here. Okay, so because do you see another sheet called Revision Year 12 Electromagnetism Answers?
Yes.
Okay, so all these 4 questions are given there, and assure you that if you do these 4 questions and remember these were the notes, so they were already posted, so you might have read those yesterday or on a Monday, and this is the revision sheet and these are the answers. So if you do these 3 things, I'm pretty sure that you will be all prepared for the electromagnetism topic. So I'm just stop sharing it and coming back here. I'm stop recording it